Welcome to Herdley, where books turn into 3 stories, refreshing your knowledge in minutes. Today, we listen to Harry Cliff's Space Oddities, the mysterious anomalies, challenging our understanding of the universe, in which we probe into the unsettling mysteries of the cosmos that defy our most fundamental scientific principles. Harry Cliff is a particle physicist based at the University of Cambridge and carries out research with the LHCb experiment at CERN's Large Hadron Collider. Don't go away, Herdley the editor will be right back with the story. The universe is full of wonders, but some of them challenge everything we think we know. Let me share 3 stories that bring these anomalies to life, each one more baffling than the last. The first story takes us to the frozen expanse of Antarctica, where a peculiar scientific experiment known as ANITA was launched. Suspended from a massive balloon 23 miles above the ice, ANITA was designed to detect cosmic rays as they interacted with the Antarctic ice sheet. For days, it floated silently, detecting nothing unusual. But then a faint, fleeting signal, a blast of radio noise, was detected coming from deep within the ice. This was unexpected, to say the least. The signal didn't fit any known patterns of cosmic rays or any other high-energy particles that should have been passing through the Earth. It was as if the signal came from something unknown, something that shouldn't exist according to our current understanding of physics. The team spent years analyzing the data, only to realize that this could be evidence of a new type of particle, one that might change our fundamental understanding of the universe. The mystery of the Antarctic signal remains one of the most intriguing anomalies in recent scientific history. Next, let's travel to the dark, isolated reaches of the French countryside, where the Large Hadron Collider, LHC, beneath the ground, has been the stage for some of the most exciting discoveries in particle physics. Deep in the caverns where trillions of particle collisions are recorded, something strange began to emerge. A persistent anomaly that suggested the existence of a brand new force of nature. Mitesh Patel and his team were on the edge of their seats as they analyzed the data. The numbers were clear, yet unbelievable, a deviation so significant that it couldn't be ignored. This force didn't fit into the Standard Model, the theory that has governed particle physics for decades. It hinted at something beyond, something that could rewrite the rules. For physicists, this was like stumbling upon a hidden doorway in a well-mapped house, leading to rooms they never knew existed. "This could be the most important thing we ever do," Patel remarked, understanding that the discovery could upend everything they had thought to be true. Our final story takes us back to the 19th century, where a small French village became the unlikely epicenter of an astronomical mystery. Edmond Lescarbot, a rural doctor and amateur astronomer, claimed to have spotted a new planet orbiting between Mercury and the Sun, a planet he named Vulcan. His discovery was enthusiastically embraced by the scientific community, led by the prestigious Urbain Le Verrier. For decades, astronomers searched for Vulcan, convinced it was the answer to the puzzling orbit of Mercury. But the planet never appeared. It wasn't until Albert Einstein developed his theory of general relativity that the mystery was solved. Vulcan didn't exist. Instead, Mercury's strange orbit was due to the warping of space-time by the Sun's massive gravity, a revelation that reshaped our understanding of the universe. "Imagine my good fortune," Einstein wrote, after realizing his new theory accounted for Mercury's motion without needing an unseen planet. These stories aren't just anomalies. They are puzzles that hold the potential to revolutionize our understanding of the cosmos. Each one represents a point where our current knowledge hits a wall, where what we think we know is challenged by what we observe. The Antarctic signal suggests that there may be particles that behave in ways we cannot yet explain, hinting at a new realm of physics beyond our current theories. The LHC's discovery of a potential new force challenges the completeness of the Standard Model, suggesting that there are forces at play in the universe that we haven't yet fully grasped. And the story of Vulcan and Mercury's orbit reminds us that sometimes the most persistent mysteries can only be solved by completely rethinking our assumptions. What ties these stories together is their ability to unsettle us, to force us to question the foundations of what we believe to be true. They are reminders that science is not a static body of knowledge, but a dynamic process of discovery. Each anomaly is a signpost, guiding us toward the next big leap in understanding. In the end, these mysteries are not just scientific curiosities, they are opportunities. They show us that the universe is far more complex and wondrous than we can imagine, and that the pursuit of knowledge is never-ending. We are standing on the precipice of new discoveries, with the potential to reshape our understanding of reality itself. As the editor of Herdley, by learning from these anomalies, we prepare ourselves for a future where the impossible becomes possible, where the boundaries of human knowledge are constantly expanding, leading us into the unknown. The universe, as we've seen, is full of anomalies that challenge the very foundation of our scientific understanding. These mysteries, from strange signals in the Antarctic ice to unexplainable forces in particle physics, push us to rethink what we know about the cosmos. But let me leave you with one last story that captures the essence of this ongoing quest for knowledge. In 2021, a team at Fermilab in Illinois made a discovery that shook the physics community. They were investigating the behavior of muons, subatomic particles that behave like electrons but are heavier. The team found that these particles were wobbling more than they should, according to the Standard Model. This G2 anomaly, as it's called, suggests that there might be undiscovered particles or forces at play, affecting the muons in ways we can't yet explain. The results were so significant that the scientists kept the data locked away for 3 years, double-checking their findings before releasing them to the world. The wobble, they reported, may well be the key to a new chapter in physics. This story, like the others, reinforces the key point. Our universe is far stranger and more complex than we often realize. These anomalies aren't just puzzles, they are opportunities for groundbreaking discoveries, guiding us toward a deeper understanding of the cosmos. As we continue to explore these mysteries, we may find that the answers lead to entirely new fields of study, expanding our knowledge and challenging our perceptions of reality itself.